I need to change this. So in Fluent, a space means enter. So if there's a space in certain places, it'll assume it's going to enter it. But I'm going to take that, copy and paste that into here and go insert file name here, paste that, and I'm also going to add a test run here. And that file name I'm also going to take down to the Fluent solver and add file name here as well. You can get rid of the test run if you want, but just have some sort of way that you guys know however you guys do your things, whatever, right? Cool. All right. So the reason I wanted to do this is that normally when you open up Fluent, it opens the working directory somewhere, right? But you don't know where that is. This might not work because this looks as if this might be a network file. But what you should normally do is copy and paste that file directory. And then when you open up Fluent, right, show more options.
Yep.
And you can see the working directory is there. Leave it here now, right?
Okay.
Meshing, that's fine, that's fine, that's fine. I wouldn't just leave GPUs out of it for now. So in CFD, all that matters is physical cores, not virtual cores.
Where do I check that from? Sorry?
No, so I've just because I've been doing this, I kind of know. Normally when it says 12 cores, it means 6 virtual, 6 physical. The best things to do though is, so if you just go start DXDIAG.
DX.
Sorry, one sec, mate. Yeah, DXDIAG.
Yeah.
You press enter. It'll run this thing. And you can see here, there's that Xenon CPU E5 2620.
Yeah.
Right, so if we just Google that right now, you'll just copy and paste Google that. Well, so is it E2620 actually? That's easy to remember. Right, and you select it, it'll most likely tell you it's got 6 cores and 12 threads.
Okay.
Right, that's why. That's opened up like that. We're going to press OK. It's just going to open it up. And you'll also be able to see in Fluent, in that working directory, there's a couple extra files that's created. Yep, so you can see that cleanup file there that's created.
Yep.
Right, if I double click that, it's going to close Fluent for me straight away. So if something happens and it crashes, that's how you can clean up Fluent real easily.
Cool. Okay.
Right. Let's just delete them, whatever. So I've got these things there. That's fine. Cool. Do you want to open up the script as well, and we'll just start copy and pasting lines into it, and I'll show you what everything means. All this stuff is just defining things, nothing special there. This is going to start the transcript, right? Name selections is fine. I think there's an error there. That should be like that.
Also, enclosure spelled wrong.
Sorry?
Enclosure spelled wrong. There you go.
Yep. Defines everything. Blah 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 blah. Cool. So if I press enter, you can see by the way I've got some options in front of me. If I select any of them, I can pretty much just go into what these options mean. Or if I press Q, I can go back.
Yeah.
Cool. Copy and paste everything in. Press OK. Everything just works fine. I get no headaches. Nothing's in red. I'm just gonna. Beta feature, so it's again, if I copy and paste that, right, press enter, copy and paste that, nothing happens.
Yeah, because a comment, right?
Just a comment, exactly. Instead of copying and pasting this, if I go beta feature access, right, if I press the middle mouse button, it copies and pastes it into the command line, right, press enter, and all of a sudden it's saying extract beta features yes. If I type yes, okay to proceed, go yes, that's fine, right? So doing that is the equivalent of putting that whole line in, right?
Okay, yeah.
So if I was to take this whole line in, well, we'll do it for file import because this is a little bit more complicated, right? So again, file, I've got all these options. If I look at import, press enter, cool, go into here, CAD options, go into here, right? Open that up. More. I'm just going to go save in right? It's done it for you. And you just press Q, 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 and it gets back to your main menu almost, right?
Okay.
You guys can have fun with that later on. If I copy and paste that whole thing into here, I press enter, it should, so it's looking for, so if I untick this, so you can see here, it's actually pasted in file import CAD, comma, sem, mm, right?
Mm-hmm.
Commas also mean yes. Commas and spaces both mean yes, by the way. So let's add that to this as well. Cool. Whatever we're talking about, by the way, we'll add comments to the top so you guys can just think, just remember it. It also makes good for me as well because I know what you guys forget. All right. So now if I want to, I can look at this, right click. I can right click on enclosure and draw it. And I've got all my drawings here. I've got this zone selection filtered, right? And if I select something and I press control right click, I can hide it, right?
Cool.
And then if I zoom in, I can see all my stuff is there. Cool. Don't care too much about that. I'm just going to start chucking things in. So I'm going to define all my global features, all these names. That's all actually already been put in, sorry. I'm going to define my global sizings, right? So if I go right click here, sizing scoped. Am I going at the right pace, by the way? Am I too quick?
Yeah, no, you're okay.
All right, all good. Well, either way, I mean, this whole thing's recorded, so worst case, you can go over it. Or we can just have another session later, right? So you can see what the min and max is right now. If I copy and paste this whole thing into, the command line, press enter, you can see that I've changed from 0.5 to 200.
Yeah.
0.5 to 200 also refers to the defined global min and max sizing that I've got in here.
Yeah.
Cool. In this particular case, I want to scope my BOIs as well. So if I do this, I'm going to copy and paste the whole thing and press enter. And you can
How would I do that without the how would I scope a BOI without entering it in?
Yeah, I'll show you that right now. Before I show you that though, what I'll do is when I select this, you can see I've got a name, it's got a type BOI, I've got a min and max. I've selected this thing and I've also got this BOI-F and there's a wildcard, the asterisk. If I do that and I draw it, it'll actually figure out what BOI-F is and the wildcard pretty much says also select anything that has anything after it as well.
Right.
Right. So if I would just go BOI-F, there's nothing that says BOI-F here. Right?
Right.
Because it has a bunch of characters and strings after it.
Okay, yeah.
BOI WildStar selects everything BOI F. Right? So you can also see enclosure. There's nothing that says enclosure or EN, which I have a bunch of times. But it'll find EN, WildStar, anything. And you can see everything's named differently that there's no other EN. Right? And my key differentiator for between my far and my near wake is an -F or -N.
Yeah.
Gotcha. All right. All good. So let's looking at the near field. So this near field is meant to be 20 mil. So let's create a new one. Let's unselect this. We're going to call it BOI-N. Right. The type is a BOI. We're going to give it 20 mil, growth rate of 1.2. We're going to select a face and edge. It's a geometry type. There's no mesh associated with it. And instead, I'm going to select this thing, press OK, right, and create it. Cool.
Yeah.
Does that make sense to you?
Yeah.
Yep, awesome. So I'm going to do the same here. I've got my front wing. Looking at this script, right, you can kind of figure out what it's trying to do. It's scoping a sizing. It's going to create something. Edge zone front wing. Well, that doesn't seem like something Fluent would say. That's something I've given it. So it's a name, right? So let's just do this as well. Let's just go Fluent. Fluent command there. And if we go space, space, space. So this is a name given.
Yeah.
Right. This is my type. This is my selection type, right? Yes or no means some arbitrary thing. Just copy and paste each one of these things in your own pace. I'm not going to go over it. We'll do the first one. Screw it. Let's just do the first one. Fine, Snowy, you convinced me.
Yeah, cheers, man. Appreciate it.
Where are we? Here. So you get that, right? I'm going to skip past all of these. I'm just going to copy and paste this in. You can also see I've only copied and pasted half the code in. It's taking me to, do I want to do this, or this?
Again, look, James from RMIT Racing, how you going?
Yeah.
Right, I'm just going to go across.
A manufacturing manager, Kieran, would have...
If I press enter, I've got all my selections here, and I can see clearly that there's edge zone, right?
Yeah.
And then it's asking me
Geometry objects, yeah, and no to what?
yes, and then no to apply to mesh, because there's no mesh object anyway, right? Again, selections. So again, I've got my front wing, and I'm going to call it a wild star. So if I have like more than one front wing kind of name selections, you can muck around with it.
Yeah, cool. Okay, so you do front wing flat, front wing 1, front wing 2, etc.
If you wanted to do that, but I wouldn't.
Yeah, okay.
Right, just to start off with, I wouldn't.
Yeah.
You got your minimum max proc sizing. So I'm just going to copy and paste this in, because they're just numbers.
Huh?
Right? Enter, and then that's it. If I also want to know what a number is, what a certain thing is, if I go, I can type in display min dash. So whatever I want to display. Enter. And that doesn't work because sizing isn't a thing. So your syntax has to be absolute size 0.05, right? You can also see it's a number. Where if I go
like, is that with respect
display
to a body of influence, or that's just your general meshing min proc size?
That one was minimum proximity sizing.
Right. Okay.
Yeah, I just put a general
don't have
proximity sizing.
Okay.
I didn't have one for the front wing, rear wing, because they're all. I generally knew the minimum. My minimum size was like 2 mils, so I know if I want 3 mils, my minimum has to be this. And then if there are other places, I really wouldn't care.
Right.
But what I was trying to illustrate before with this one, if I go display, I don't even remember the displays. I'm just going to display study. Right, you can see it goes test run. Cool.
Yeah.
So you can check things by going display something, right? So I'm going to do the same here, copy and paste it into here. Right, you can also see straight away I've got these things. So you'd use to start off with your GUI to double check what you've just done. Right? You can triple click on these. You can draw just the front wing if you need to. Again, this is just a checking mechanism. Right?
Mm-hmm.
You with me, Snowy?
Yep.
Cool. Rear wing, you don't have one. So we'll add the diffuser. And I'm going to add the car. You don't have a stand, and that's pretty much it, right? So that's all your sizings.
Mm-hmm.
Right? Normally, you then compute the sizing. So this is already, okay, so it looks as if there's something that's been added that's incorrect. Probably the chassis. Yeah. So in my previous ones, I didn't give the chassis a name. I just left it as nothing. And what happens is that it'll just give it an enclosure name sizing.
Okay.
Right? So in this particular case, it's saying, obviously you can tell there's an issue here. And I'm just going to give it chassis. And now if I take that previous command in, so that might change some things down the line. If I go here. So if I press up, it just figures out what's next. Oh, what have I done? All right, let's just have a look through these. Oh, oops, I didn't modify it. So I went to here, I wanted to change the chassis, press OK, and I got to modify it. Now it's changed it. And if I press up, enter, it'll figure out my proximity sizing, right? This will then write out a size field. So it'll pretty much write out a field that says, this is how big the mesh is, this is where it is here, this is where it is here, right? And then you have to re-import that mesh in. So I've just found this is the most stable way of importing a mesh, right?
Right.
And the other thing, yeah, for debugging as well, just do it this way. I've just personally found it's cleaner, it's easier, it's robust. That's the other thing you'll find with a lot of this stuff. You generally do the things that aren't necessarily the most efficient, but the most robust. So when you give it to someone else, it doesn't screw up.
Right.
Yeah. Cool. What else? Let's add to check out a name, display, and then what is it? Just a not file name. What is it? I can't English. I can't English, man.
A label.
Label. Cool. That works. Right. Is there anything else? What else should we add to this comment section at the top? Just so we don't forget. And it also means next time when you give it to someone else, they can look at the top and be like, okay, cool. Let's add the comment saying, make the code as robust as possible. Cool.
Yep.
Right. So let's just close this. Right now, if I have a look at this meshing settings, I can right click, draw it. And then if I go into my display, I've got face edges that I can check out. It's a bit fine, but you know, look, you've got something you can muck around. You can change the fine. You can change everything later. Right. And then what you can do, you can right click, you can press summary and it'll show you what the summary of everything is. You've got some bad skewness parts here. If we right click on that, we can go diagnostics and check out connectivity and quality. Right, so if we go to quality, it looks as if the worst ones are like 0.998. So if we mark them, you'll also be able to look at that, and if you go first, it'll show you where the bad quality elements are, right? Yeah. So you can see, I mean, it's just, there's nothing that bad. It's just a weird element that it's put in. If I press up, it'll show more mesh. So it'll generally show me where my bad quality element is.
Yeah.
Right. So is this, yeah, I think this is where the diffuser is. So it's just a small pinch kind of thing. That's not a big issue. When things come to sharp angles, normally, if we go to the next one, sharp angles will cause bad issues as well. So you can see, I mean, that's just the mesher kind of. The first pass doesn't make the best mesh, right? So what you can do afterwards, if you just reset this and draw, all right, so if we look at our summary again, what was it? We've got 26 with 0.99 being the worst, right? So if I do this very first one, it'll improve the quality of the surface mesh. It should. You can generally see what it's done. If I go right click and I check out my summary again, I can see it's 11 and the worst is 0.97.
Okay.
Right? So if I do the same for these three, it's again, right, if you want to like a super in-class detail, you know, thing about Fluent meshing, we have to do this later. There's a lot that you can do with the tool. I'm just trying to show you what you need to know right now just to get you working and using all the FSAE stuff, right? 2 and there's 0.97. So if we have a look at that, chances are it's just a bad element due to geometry, right? So you can see roughly what's happening there. So it's just a very thin.
I think I've seen Rob doing it the other day. And then it's gone.
Yeah, you can. So the next one, oh, that's right, because you're working with Rob.
Yeah.
So by doing this, so you'll generally be able to figure out what geometries make weird cells, so you can avoid it.
Yep.
Right? So this is general improve. I've got a bunch of collapses in here as well, and then it generally improves twice over.
Okay.
Right? So if I do that again, I'm just going to copy and paste all of it into here, and it'll just do its thing. You can see snowy as well straight away. After it's collapsed those really bad things, your worst skewness is 0.6.
Beautiful.
Cool. All right. And then we want to compute your enclosure, which will do it. Right, so if you look at this volumetric, it's computed, it's a volume. So if you need to, you can convert it to a fluid if you want to. Right, that's fine. We've got our poly controls here as well. So this is poly size fields. And we want, let's just do this one by one. Right, and now when we want to add inflation, this is what we're doing here. So meshed, scope, prisms. Prisms are the same as inflation. Elements, fluent meshing, front wing. There's a last ratio, first cell height, and then enclosure, and the name selection at the very end as well, right? So if I copy and paste all of that into here, right, it'll create itself. Nothing's giving me errors. If I right-click auto mesh, I've got my scoped prisms here, and I go set. I can see it's created exactly what I needed for me. It's using a last ratio. First cell height's 0.3, number layers 3, 20%, and it's also selecting the front wing. Sorry, what was that, mate?
Can we look at that? Can we go into the window and look at the inflation that's been created?
No, because you haven't actually created the inflation. You've just told it this is what I want to inflate. Okay. So afterwards we will though. Cool. Yep. All right, so let's just close that. Let's close that. I don't want a rear wing because I don't have one, and I want my diffuser, which works, right? And however, right, remember we were talking about this, our chassis isn't actually a chassis because that last three things is just N.
Yep.
Right, so let's just change it to chassis, press enter, and that's going to work for us. And then the other thing that we're going to do, we're just going to add some prism layers on the ground as well. Screw it.
So you're changing N star to chassis, right, in that case?
Yeah, that previous one was just N star to chassis. If we just go auto mesh, good. What I'm going to do, this is how you normally do it. Let's just create the front wing. I'm going to delete the rest of them only because of time requirements. It's just more elements. It'll just take longer to run and solve. Cool?
Yep.
Yep. Awesome. Close, close. Polyhex core. And so pretty much what you're doing in here, auto mesh, I'm going to polyhex core, and it's just going to run it, right? So instead, we're going to just use this function, and this takes a bit of time. Nice poly surface. Again, I'm just going to get rid of everything here. All right, everything's poly on the surface. Nice. If I select, say this flat surface here, around here-ish, right, I can go, I want to see Z values, right click, and I want to see Z in range. Just orientate myself properly, and when you go closer in, you can see poly layers and all your other layers in between as well, right?
Right.
See also, where's it, your front wing? Can you see? Oh, that's a
Is that inflation?
Sorry?
Is that inflation? Okay, I see it.
Yes, you can kind of see 3 layers of inflation there because you see the layers, right? And it comes out there. Yeah, and that's pretty much it, right? And then you normally have inflation on the floor. You can see this clearly doesn't have inflation.
Why would you have inflation on the floor? You'd have inflation on
because you want to capture the pressure gradient. So having just a couple of layers just makes it uniform and makes it nice.
Okay.
Right?
But then that would run all the way along the floor.
Yes, it would.
So that you can maybe. Yeah. Okay.
Yeah. I mean, look, it's difficult, right? The only thing I can really say to you is just test it, okay? If you're not sure, test it. Do a run with, do a run without, understand what the difference is, and then you can justify your changes.
Right.
Unfortunately, there's no one way I can, the only way I learned is just by doing shit, failing, and then doing it again. Unfortunately, there's no way for you to do it apart from doing that, and it just means time.
No worries.
Right. So if I just go summary, right, you can see Cool. That's actually a really good cell count. That's a good cell count because I don't have inflation on everything. As soon as you inflate everything, it just causes errors. Well, it can cause errors if you have bad geometry, and normally everyone has bad geometry.
Has quite a bit of difficulty with inflations as well. Is that
Sorry?
correct? Fluent can have a bit of difficulty with inflation as well. Is that correct?
No.
No.
Look, man, like it's a difficult question, right? Because there's no answer to that. It can have troubles with inflation, right? But if it has troubles with inflation, it most likely means your mesh settings are not correct or your geometry is incorrect, or it's creating really bad surfaces, which means you need to go back to geometry, fix geometry up, and then take it back in. The difficulty is that if you don't understand that, you can stand here for the next day trying to change the mesh setting to figure out why it's better, not knowing that the truth is you're just making a really sharp angle in geometry that needs to be fixed.
Yeah.
Right? So it's like that's the hardest thing, right? I know when things go wrong from experience. Unfortunately, I can't teach that to you, which is one of the reasons I always say if something goes wrong and you persist a couple of times and it's screwing up, just come to us. Maybe we'll be able to tell you what it is earlier. Yeah. Does it make sense?
Yeah, no, I got you, man.
Yeah. All right. So that's done. Remember, this thing has come in as Fluent's normal thing is meters. So even though it comes in as millimeters, it actually scales everything up. So we're just going to scale everything down, right? We're going to prepare to solve. Prepare to solve is just going to get rid of crap we don't need pretty much on the geometry and the meshing side of
Before we
things.
do that, I just want to quickly have a look at how would I, if I wanted to put the inflation on the rest of it right now, could I just copy and paste everything we didn't copy and paste in that inflation section and into that and just hit enter?
Well, you'd have to delete the cell zone that's created.
Okay, so
But in theory, so you go right click here, delete it. But then all you need to do afterwards, after you've deleted it, go to your auto mesh settings, set, add the extra couple ones afterwards, and then remesh it, and it'll add all the inflation afterwards.
Okay.
Right? Cool. I'm not going to save this out because it just takes a bit of time. Yeah, I'm not going to save it just because it's going to take a bit of time, and then you switch to solution, right? The rest of it's actually not that difficult. The solving part is actually really easy.
Yeah.
Right. Again, Fluent Solver, so let's just do its thing. We don't have wheels, so we're not really going to bother a huge amount with it. But let's just copy and paste everything in right now. Actually, what I'm going to do, I'm going to just change this to one iteration. Right. So let's copy and paste all of that in right now.
So that's what wheels is.
Wheels as well, but it's just defining wheels. It's not actually telling you what the things are, right? So model type, K-Mega SST correction factor, yes. So when we go into here, again, double check, right click, edit it, K-Mega SST with curvature correction. Cool, right? All right, these are all good. These are all good. Wall, yep. Let's just do all of these, and there's no front wheel, so that'll kind of just not need itself. So it's, again, you can go through, you can double check everything on the left-hand side afterwards, right? So for instance, my PV, so if I have a look at my controls, methods, this is using a simple velocity scheme. If I copy and paste that in, it should change this to coupled, right? You can see that.
Yeah.
Cool. And then what I'll do afterwards, I'm just going to copy and paste all this in, right? I'm not going to add lift reports because you've just got a front wing. This normally just writes it beforehand, but then this will initialize it and this will run it. All right. So let's initialize
I can usually do all this stuff without the script. It's just the meshing that's wigging me out.
Oh, right. All good. Okay, so the rest of this stuff is okay to you then?
Yeah. It's been fine. Doing the rotating wheels, I understand how to do it, but I think I'll probably I haven't done it yet. But so you have to know the origin.
Yeah.
Your wheel, like center point origin, right?
Yeah, exactly. Yeah. Because when you
And
do it, it's a wall with a rotating or a rotating wall, sorry.
Yeah,
So you
exactly.
need a 0, 0, XYZ coordinate. You need to give it an axis. You need to give it a rotational component afterwards.
Yeah.
Right. Just letting you know, it's solved. That's fine. And you can see it gives an elapsed time in seconds.
Yeah.
Cool. Reports. This one right here is super handy because it'll tell you. So I'm just going to full screen. It'll tell you how much gig was used. You can write out this whole file using this second one. Let's do it because just to make sure you've got memory.
What's writing out the file do?
It's just saving out the case and data file. So the case is just pretty much how everything's set up. The data's data, and then what you can do, you can read in a case and data file afterwards.
So that you need to save them both separately, a case file and the data file, and import them separately as well.
No. This file. So you can see on the left-hand side, file,
Okay.
write, case and data, right?
Yeah.
So that'll actually write out case and data together. You can write out just the case because that way it's a lot less, right? You can see when this thing is done, we can have a look at it, but it can be just an issue with size, right? You can have 2-3 gigabytes of a case file. You can have like 50 gigabytes data file. You don't want to be sitting at 51 over. So you can send me just the case file. I'll solve it, and then I've got everything done. But you can see size functions, blah, 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 blah.
If we start getting like
case
big
file that's
files,
100 meg, right?
Yeah.
And then, all right, so I didn't add a closed transcript, so let's just figure out how we can do that. So if we go File, press Enter, and then there should be some sort of, so there's a start transcript there. There's a stop transcript there. All right, so if I that, press Enter, transcript closed, awesome. So what I'm going to do, I'm going to copy and paste that into here. Press Enter, File. So it's just going to be that, and that's it. Right?
Cool.
You with me there? And then what I'm going to do, I'm just going to hit Exit because file doesn't mean anything. I'm just going to get out of it. Sorry. Exit. And it's going to exit it. So I'm going to save what's on the left-hand side, and the other cool thing is this transcript file. The whole reason I've been saving this out is you can open this up in Word or Notepad or whatever. I have Atom, but you can use like Notepad++ or something like that. Have a proper text editor. This is everything that we've done, right?
All right, cool.
Cool. So what happens if something goes wrong? You tell them to send you a transcript file, which is what I'm going to do to you. Send me a transcript file, and that way I'll be able to look at this and figure out exactly what you've done and figure out where something's gone wrong.